In this video, we are going to talk about strong versus weak acids and bases, the properties of strong and weak acids and bases, Arrhenius and Brønsted-Lowry acids and bases, and how to identify a strong versus weak acid and base. For strong acids, all of the protons will dissociate or break apart. When all of the protons dissociate, this is called 100% ionization or complete dissociation. The best definition that we have for acids and bases to explain strong acids is the Arrhenius definition. An Arrhenius acid increases the concentration of H+ in solution, or H+ is a product. And this is exactly what a strong acid does. One of the strong acids is HBr. HBr will have 100% ionization, creating H+ and Br-. HBr increases the concentration of H+ in solution, which we can see as H+ being a product in the equation. For strong bases, all of the hydroxide ions will dissociate or break apart. When all of the hydroxide ions dissociate, this is called 100% ionization or complete dissociation. The best definition that we have for acids and bases to explain strong bases is the Arrhenius definition. An Arrhenius base increases the concentration of OH- in solution, and this is exactly what a strong base does. One of the strong bases is KOH. KOH will have 100% ionization, creating K+ and OH-. KOH increases the concentration of OH- in solution, which we can see as OH- being a product in the equation. For weak acids, only some of the protons will dissociate or break apart. When only some of the protons dissociate, this is called partial dissociation. We use a general formula HA to describe a weak acid. The best definition that we have for acids and bases to explain weak acids is the Brønsted-Lowry definition. A Brønsted-Lowry acid is a proton donor or donates an H+. Using the general formula for a weak acid, HA, a proton is donated to create H+ and A-. A- is the conjugate base. Weak acids will have conjugate bases on the product side of the equation with only an H+ difference in formula. For weak bases, only some hydroxide ions will be created. When only some of the hydroxide ions are created, this is called partial dissociation. We use the general formula A- to describe a weak base. The best definition that we have for acids and bases to explain weak bases is the Brønsted-Lowry definition. A Brønsted-Lowry base is a proton acceptor or accepts an H+. Using the general formula for a weak base, A-, a proton is accepted from water to create OH- and HA. HA is the conjugate acid. Weak bases will have conjugate acids on the product side of the equation with only an H+ difference in formula. Weak acids and bases will only partially dissociate into ions and will create an equilibrium between reactants and products where both will still be present in solution. To describe the amount as a ratio for products and reactants that are present at equilibrium, we have an equilibrium constant K. K will be equal to the ratio of products to reactants at equilibrium. Weak acids have Ka values to describe the ratio of products to reactants at equilibrium, and weak bases have Kb values to describe the ratio of products to reactants at equilibrium. Ka and Kb values are usually much less than 1, and this tells us that we have more reactants than products when the reaction reaches a constant point. There will be a spectrum for how we can categorize weak acids and bases relative to each other. Some weak acids and bases can be stronger than others, meaning they create more protons and hydroxide ions at equilibrium. The value of Ka and Kb will help us to measure the strength of weak acids and bases. The larger the Ka value, the stronger the acid, and the larger the Kb value, the stronger the base. All acids and bases are conductors of electricity. Strong acids and bases will be different from weak acids and bases in the amount of products that can be created. Strong acids and bases have 100% ionization, and weak acids and bases only have partial dissociation. This leads to different conductivity rates due to the varying extent of ionization for strong versus weak acids and bases. Strong acids and bases are strong electrolytes and strong conductors of electricity due to 100% ionization, while weak acids and bases are weak electrolytes and weak conductors of electricity due to only partial dissociation. The best visual that we have for the difference between the two is a conductivity test. The intensity of the light emitted during the conductivity test serves as an indicator of the extent of dissociation, with brighter light signifying a higher degree of ionization in strong acids and bases compared to the dimmer light produced by weak acids and bases. Strong acids and bases will produce a bright light due to complete dissociation of the reactants to make products. Weak acids and bases will produce a dim light due to only partial dissociation of the reactants to make products.